Welcome to the latest video, and in this video short, well, what we're excited to announce is the publication of the Six Sigma Black Belt Handbook. 400 pages of golden advice on how to become a world-class black belt and earn double your normal engineer salary, because that's what being a world-class problem solver is all about. This is a how-to book. It's not a statistics book. So you are going to become a brilliant engineer. If you buy this book, you are going to become a brilliant black belt. Go to lulu.com and look for the Six Sigma Black Belt Handbook by Paul Allen right now. Welcome to the latest video, and in this video newsletter what we're going to take a look at is DOE high and low settings. So this is just a quick video to talk to you about how do you choose your design space in a designed experiment. How do you pick your high and low levels? Now, of course, what we're interested in is understanding the model that is available in your system. So let's say this was just temperature, and the thing that you were trying to understand was the strength of something that you're producing. This is the system that you're trying to understand. So there is obviously over here, there is a low temperature, there is a high temperature. This design space is everything that's available to you. All of that knowledge is available to you. Now, what you could do by accident is you could choose your design space to be very close, especially if what you're trying to do, of course, is maybe there's a target that the customer wants you to hit. So you might be tempted to test around the target, and then of course you lose all the other knowledge. So typically what we do is we encourage you to go out as far as you reasonably can, so that maybe you don't go the whole system, maybe you go this far, and what you then do is you're testing there, you're testing there, and the knowledge that you gain is that model there. So high and low settings, typically you want to get out nice and wide. But there is potentially a problem with that. So we have to then temper it with other advice. And it's this problem right here. So if your system tops out, so let's say it's not strength. I know, we'll leave it at strength. It could be strength that you're looking at. So it's still strength that you're looking at. But maybe what happens is you have your temperature here that you're interested in understanding. But what happens is the strength has a maximum. So it does this. The effect rises very quickly and then sort of tops out. Now, the trouble with that type of system is, of course, you don't know where the knee of the graph is. So when you open your design space up, there is a danger that you might test here and here and fit a model that looks like that. Now, that might not be the worst thing in the world, because you could tidy that up with a 3-level DOE, and maybe the curve might work. But it depends how tight this turn is in space, and of course how far over here you go. It is possible, because of the fact that this tops out here. And of course what you would want to do is you would want to test there and there. So that then becomes the knowledge that you learn. It's true knowledge, the model works really well, and everything's right with the world. but you don't know where the knee of the graph is, and you don't know how tight the turn is also. And there's the problem. So if you know in your system that the likelihood is there is only so far the input factor will drive the output factor. This is especially true, of course, if you're looking for 100% effect or zero effect. Once you hit either of those 2 points, of course, the model tops out. So you've got to be careful. Get as wide as you can. But if you know that the model tops out, it could be that you do a little bit of pre-work to try and figure out where that effect is. That might be the solution. But you've got to be careful when the model tops out. If you don't think the model tops out and it just keeps going, this isn't so much of a problem. The best thing though is nice and wide. So there's a little bit of advice. How do you choose your design space? As wide as possible to get as much knowledge, but be careful. If you run into those top out or bottom out regions, your model might not work, and that could be the problem with your DOE. That's how to look at the setting of your design space.